So we're going to move towards aldehyde and ketones, but before that, did we study acids? ठीक है, alcohols are weak acids. ठीक है, we did that. तब ये कि aldehyde and ketones. एक quickly ना, let's just uses of alcohols. ठीक है, तो ये बस simply copy कर लेते हैं कि they use frequently as solvents. Medicines वगैरह feedstock. ठीक है, like basic chemicals from which you make different stuff. ठीक है, drinks, spirits, etc. Fuel, methanol is a fuel. ठीक है, all of these. तो ये इधर ऐड हो गए and so now the next thing is aldehyde and ketones. They're carbonyl compounds. So aldehyde and ketones. अच्छा, इसमें ये कि aldehyde and ketones are both known as carbonyl compounds. They've got a C-double bond O. ठीक है, anything that's got just a C-double bond O, that's a carbonyl compound. And this is your carbonyl functional group, that it's going to have a C-double bond O only. अच्छा, अब इसमें ये कि since that is a carbonyl compound, aldehydes and ketones, the only difference between the two functional groups is that the C-double bond O is right at the end of the chain. So you're going to have R, C, and then you're going to have double bond O. And after that, there's going to be an H. Ketones, kind of what will happen is that the C-double bond O is somewhere in the middle of the chain. So you'll have C-double bond O. And on both sides, you'll have a carbon chain. So for example, अगर मैं दो draw करता हूँ ना, so here's one molecule. ऐसे इसका मुझे नाम बता दो. What is this called? पहला वाला क्या होगा? Hunaid, what's the name for the first molecule?
Sir, is it propan 1-on, sir?
Is it an aldehyde or a ketone?
Oh, sorry, sir. Propan 1-ide.
No, aldehydes
Oh,
have EL as a suffix. This one, what's this one? ये क्या होगा? This is, what's 4 carbon atoms?
butan 4-on, sir. Butan 2-on, sorry, sir. Butan 2-on.
ठीक है, that's butanone or 2-on or 2-butanone. But anyways, that's the name of this molecule, and the suffix is going to be on. Okay, that's the first thing about this particular functional group, that it is a polar compound. This functional group has the carbon is positive and the oxygen is slight negative, so it's a polar molecule. So this one is a polar molecule, and it will have permanent dipole attraction. So permanent dipole attraction. Now, aldehyde and ketones, we've done pretty much most reactions of aldehyde and ketones that they get oxidized. Now, the first thing is we learn how do you identify an aldehyde or a ketone. So, identification of carbonyl compounds. So, identification of carbonyl compounds. So the identification test for this is, and carbonyl, remember, is both aldehyde and ketones. So what you do is that you add 2,4-DNPH. DNPH, that is 2,4-dinitrophenyl hydrazine. So it's dinitrophenyl hydrazine, and the formula of this thing is it's NH2. Then there's an NH, C6 H4, and then NO2 twice. These are different ways in which the same molecule is represented, and they might actually draw the full displayed formula as well. So it's this thing followed by, there's going to be a benzene structure, which is a ring structure which has and it's got a it's going to have a ring in the middle, and there's going to be NO2 attached at 2,4-dinitro. Yes. So they're going to be two NO2s that will be attached to it. So this is 2,4-dinitrophenyl hydrazine. It's this molecule, and what this molecule will do is that when you add 2,4-DNPH, the result is going to be you're going to get an orange precipitate. So that's going to be your result. Very rarely do they ask you to actually draw the structure or write an equation. Very rarely. Okay, so most likely never. That's never going to happen. It has happened once. So you're going to get an orange precipitate. It's going to get PPT like that, then precipitate. And the reaction is this, that when you have this 2,4-DNPH, there's a condensation reaction that actually takes place where you have, if you have a ketone, the ketone has serial bond O, and it's got a carbon chain, or an aldehyde. It could be for both, or if you have an aldehyde as well, that's what a ketone looks like. What will eventually happen is that So what will eventually happen is that the H and the O will join up, and they'll end up forming water molecules, and the the other product, that's a water molecule, is going to be a byproduct. It's going to be a condensation reaction. So you're going to get water molecules, and these two will join up. So this ends up joining with this. So these two molecules basically end up joining with each other. Let's go. So, and the water molecule in between that leaves. So that water is gone, and the two things, they connect with each other, and that basically results in your orange precipitate, which is this entire thing. But anyways, in most cases, just once, TK, they actually ask for the equation. The only basic thing that you should remember is that you add 2,4-DNPH and you get an orange precipitate. That's it. And so the other thing about this is, how do you differentiate between an aldehyde and a ketone? So first thing is, you're going to identify whether it's a carbonyl or not. And the next thing is whether it's an aldehyde or a ketone. So the answer to that is, we've already learned that answer, that aldehydes, they do get oxidized, and ketones, they don't. So aldehydes get oxidized, and ketones don't. So we've already learned about this previously as well. Okay, यहाँ पे था ना. So an aldehyde can be oxidized by all these methods. So that would be helpful in identifying aldehyde. Or ketones don't. Ketones don't undergo further. They don't undergo further oxidation. So ये सारे tests up, you can do this, and they can be used to figure out oxidation happening or reduction happening or whatever. So that is how you're going to differentiate between the two. So next thing is, so we've identified aldehyde and ketones, 2,4-DNPH for both, and differentiating between them. And remember, you have to do both tests to confirm, because a lot of things get oxidized. So you have to first confirm whether it's an aldehyde or a ketone. So 2,4-DNPH. So the next one is, the aldehyde and ketones, they also undergo a nucleophilic addition reaction of, so carbonyl compounds and nucleophilic. addition reaction. So for this, let me just double check whether this mechanism is now in A2 or AS. Or have they? Just a second. Let's see here. 2 for DNPH, we did that. Nature of the carbon from the results of simple test, fell in the intolerance, we did that. Describe the mechanism of the nucleophilic addition of hydrogen cyanide with aldehydes and TK. That's reduction of aldehydes and ketones with. So reduction, oxidation, all of that done. I guess, and this is AS, right? And this is AS. But still, the mechanism is still there. So the mechanism of this reaction is, I'll write down the reaction first. It's known as nucleophilic addition. Now what happens is that you take, and remember it's for carbonyl compounds. So if I take let's say any aldehyde or ketone, the carbon is positively charged and the oxygen is slightly negatively charged. What happens is that when you add Cn minus one as a reagent in this reaction, the Cn minus one, the carbon has lone pairs, and those lone pairs they get attracted to the carbon that's positive. And as this negative ion gets attracted, the electrons over here in this pi electron cloud, they get repelled. Next step is so the next step is that the Cn at the bottom, it joins up with its lone pairs getting attracted to the carbon, which was positive. So the Cn has joined. And Cn minus one, the electrons over here, they get repelled. So you no longer have a double bond. Instead, you have an oxygen. The electrons have been pushed upwards. And you've got a negative charge now, a full-on negative charge. So that is what has happened over here. Now the other thing is this molecule now, this intermediate, which is a negative ion, is now going to get attracted to H plus one from HCN. And the electrons over here are going to get attracted to it. And eventually it's going to form OH at the top. Everything has to be drawn exactly the way it's drawn over here. और बस इस OH को फिर जोड़ देना है. So this H plus one will get attracted to the oxygen, which is negative, and they will eventually make a bond at the top. और गलत वाले के साथ करते हैं, एक सेकेंड. So that's the final. So that's the final product. Okay, that's a final product. And that's the mechanism. Okay, so the idea is simple. Cn-1 comes in, joins with the carbon, the electrons get pushed upwards. Oxygen becomes negatively charged, and H+1 then comes in. And it eventually, so it eventually bonds with the oxygen and forms OH. And this thing is known as a cyano. जो ये क्लियर है सारों को
जी
और इसका सिंपल
सर।
रिएक्शन हाँ तो ठीक है इसका सिंपल रिएक्शन ये कि you've got a RC double bond O and R and what you do is you add the reagent is HCN and you also need NaCN as a catalyst. And what you get is this thing. So this is what you're going to end up with. And the first Cn-1 actually comes from the catalyst. To start the reaction or to speed up the reaction. So that's it. That's the nucleophilic addition reaction mechanism. And you've got to remember the mechanism. They'll ask you to draw it. It's a two-step reaction. And you've got an intermediate over here. यहाँ पे मैं लिख भी देता हूँ it's a two-step. It's a two-step reaction. So I guess that's it about carbonyl compounds. So oxidation reduction. This is alcohols. We did alcohols earlier, so that's done as well. Esterification, kar lete hain, that's we haven't done that. अच्छा बाकी अच्छा triiodomethane that's also left. ठीक है, that's again triiodomethane. We'll do that. Carboxylic acid, because it's mostly O-level stuff. ये सारे हम कर चुके हैं. Addition polymerization, we did that. बस ठीक है, जो चीजें रह गई वो कर लेते हैं. अच्छा, so there's another reaction which is triiodomethane. It's known as the iodoform reaction. It's an identification test. अच्छा, iodoform test जो है ना, that's a test for identifying a structure, not a functional group. And that specific structure looks like this. It's It's either a double bond O with a CH3, a methyl with a acetyl bond O, carbonyl group. And then you've got a carbon chain or an H over here. The other one is that it's a methyl with an OH. So यहाँ पे there's a methyl group. And again, you've got on one side you've got a carbon. R, remember, is representing a carbon chain or an alkyl chain. So it's got a carbon chain or an H attached to it. So it's specifically it measures the or it identifies these two structures. It's either got to be a methyl with a ketone, to be molecular if it has that. तो ये part होना चाहिए. Or it has this structure. So the molecule, if it has these two structures, what will happen in the iodoform test is, okay, this particular structure, we don't care about the rest of the molecule except these two structures, they will eventually break in the middle when you do an iodoform test. They're going to eventually break in the middle. And when they break, this side in both cases will turn into CHI3, which is known as triiodomethane. And you'll get a yellow precipitate. And what happens to the other side is that particular carbon atom will turn into a salt of the carboxylic acid. So remember that particular carbon atom turns into a salt of the carboxylic acid. And the conditions needed for this iodoform test is NaOH aqueous plus iodine. That's the conditions. And you're going to get a carboxylic acid, except that alkaline conditions the carboxylic acid reacts with, because you're using NaOH. So your RCOH group ends up reacting with the alkali, which is why you end up with a salt. If you don't want to end up with a salt, so further acidification at the end, I mean, you might add an acid at the end. ताकि वो excess alkali react कर जाए, can form. Otherwise, your carboxylic acid will end up reacting with it. So that's known as your iodoform test. So whenever you see a structure where you have got a methyl with a acetyl bond O, or a methyl with this structure, COH and H, the iodoform test will be positive. No matter how complicated the structure is, the CH3 will break off and it will form CHI3. It's going to form a yellow precipitate. Okay, is this clear?
Yes, sir. So in this one, do they ask us for the equations of the products again, or do they just ask for the colors?
Usually they just ask you for the product. Usually they don't ask for equations. They just ask for the products. What are the products? Okay, ये मैं देखूँ ना, 1 second, where's the... So I guess we're done with the carbonyl compounds. Mostly olefin stuff is now left, like esters and... अच्छा यहाँ पे ना carbonyl, where's carbonyl? ठीक है, aldehydes, carbonyl. अच्छा अब यहाँ पे ना, so you're saying so this is a 2,4 DNPH. So we'll do this question. Let's do some questions. 2,4 DNPH, that's an aldehyde or a ketone. So that removes carboxylic acid. That removes so the first three are aldehyde and ketones. I mean, this one is a ketone. I think this one is not a ketone. So that's also gone. This one is also a ketone, serial bond O. This is not a ketone because it's serial bond O with an O. Ketone is just serial bond O. It evolves hydrogen chloride when treated with PCl5. Alcohols do that. So C is going to be the option. It is neutral. Alcohols are neutral. Aldehydes and ketones are also neutral. So next one is, I guess that's an ester, so forget that. So we can forget this one as well. मैंने बताना था. So you got two groups, and these are double bond O's. It's double bond O, and this is an aldehyde and this is a ketone. So 2,4 DNPH, that will identify both Q and R, both of them. But Felling's reagent, that oxidizes. Only aldehydes get oxidized, so that's R only. Ketones don't undergo any oxidation. So next one is that he's turning it. So this one is related to carboxylic acid. Forget that. In the reaction between an aldehyde and HCN catalyzed by NaCN, which statements are correct? A new carbon-carbon bond is formed. Is that true? So we did the aldehyde and the HCN and NaCN reaction. So a new carbon-carbon bond is formed over here. CN goes and bonds with the carbon, so that's a new carbon-carbon bond. In the intermediate, the oxygen carries a negative charge. That is also true. The oxygen has a negative charge over here. Up here, okay, the last stage involves the formation of hydrogen-oxygen bond. That is also true because in the last step, the oxygen and the hydrogen, they bond with each other. So up next is वो मैंने बताया था iodoform. Actually, sorry, iodoform is a new test, so most of the old questions they won't really have the iodoform test. उसको वैसे देख लेते हैं एक सेकंड. Yes, छोड़ दो, भी नहीं मिलेगा. So बाद में we'll practice this iodoform test. Is I'll just do one question. For example, this one will not give a positive iodoform test because it doesn't have it's not having methyl, a CH3 group next to a serial bond O. Let's try and find out again this one, methyl not with serial bond O. That's not going to give you a positive iodoform test. I guess this one will have a positive iodoform test because you got a methyl and that's next to a serial bond O. The methyl in the iodoform test will break off and it will form CHI3, which is your yellow precipitate. So that's gone. And the ketone over here will turn into a carboxylic acid. Is that clear?
Yes, sir. Yes, sir.
So that's your iodoform test. चलो ठीक है, बाकी फिर करते हैं कंप्लीट कल. I guess carboxylic acid, nothing really new in carboxylic acid, just the same old. Oh, esters, ठीक है, that's the same old stuff. Aqua hydrolysis of nitriles, we'll do that as well. I mean, that's also simple, basic reaction. You just need to know what the products are going to be. So ठीक है, कल कंटिन्यू करते हैं, ठीक है?
Okay, sir. Allah.
चल, okay, हाफिज.
Okay, thank you, sir. Hafiz.